Okay, as promised, here's a video where I'm going to go over the um, the insert function that we did today. I think the other functions in order print's a little bit easier, but we'll talk about it anyway. Okay. So a lot of this was done for you. So we have the tree node up here. Here's the definition. Okay, and we'll call this an ADT. It's not really in that it's not an abstract data type, but you get the idea. So remember we talked about you have to have the public function that's very simple, just insert number. And then you have the helper function, the same name, but it includes the node. The node is necessary since we're going to do recursion. Okay. So that's all done. So the private insert is pretty straightforward. Okay. It just calls the insert function, the other version, with root as beginning node. Pretty straightforward. Okay. The other insert gets a little more complicated. And so many people are trying it so many different ways that it's hard for me to keep straight the best way to do things. I guess I need to have a fully worked out solution that I can refer to in my head when the questions confuse me. The questions themselves don't confuse me. It's the different questions from different places gets difficult. Anyway, so some of your answers I think were a little more complicated than this, but if it works, it works. Okay. So the insert, we're going to be sent along a node. First time it's root could be whatever. Okay. So we don't need to worry about keeping track of where we are. We're always at node. Okay. So we can check if node's equal to null pointer here, even if it's the root node. If it's the first time that you try, if root's equal to null, then it's going to take care of this. Some of you were having to put this in the public one, which if you have to, you have to. But I mean to make your code work, but it's not necessary. We should be able to do it right here. So it's going to say if the node's equal to null pointer, then that node, whether it's root left, left, root left, right, whatever it is, we're going to set that node equal to the tree node at the value. Okay, so we're going to we're creating the new tree node at that value if it's null, and we're good. So this is either on the root node when we're done, or this is on 20 nodes down when we hit the null. Okay. And this star ampersand is a weird thing with C++. And basically what this is saying is that we may want to have to change this pointer as we go along. So that's why we send it this way, just as a safety measure. Okay. So that's our first option there. The second option here, if the value that we're sending in is less than the node data that's there, okay, we're going to insert node left value. Okay. Again, if this turns out to be empty, then when it gets to its own version, this first option will kick in and we'll be good. Okay. Else if the value is greater than the node data, we're going to insert at node right value. Okay. And again, I didn't do anything here, but we could have an else on the value equal to that, or we could print out a message if you want, but you don't have to make it work. Okay. So then the in order print should look similar to what we did in class, in lab yesterday. So it's pretty basic. The public version, again, you just call in order print with no parameters, and that's fine. Okay. But for and that just calls the private version, the helper function that really does the work with root. And then I've just got a print line at the end just to separate things out. Okay. Because I'm going to print mine all on the same line. So here we've got, as long as the node doesn't equal to null pointer, we're going to go ahead and do these things. Okay. And so if we get to a null pointer, there's nothing to print. So we don't, we're done. Okay. But if not, we're going to call the in order print on node left first. Okay. Then when we come back from that, when that finally gets done, we're going to go ahead and print the node data. Then we're going to call the node right. Okay. And that's really all there is to this function. Okay. So we can take a look at the C19E1 then. I think this is more or less what I asked you to do. Got 1, 2, 3, 4, 5, 6, 7 numbers randomly put in there. Okay. We're going to insert them. We're going to print them out. Okay. And this in order print is an easy test, right? Because we can tell if they're not in order, then either our print doesn't work or they weren't put in the right order. We saw from the lab yesterday, if you have a tree that's not a binary search tree, your in order print will not be in fact in order. Okay, so that's kind of the issue. Okay. So we can go ahead and run this one here. Okay, and do the A dot out, and you see there, it's getting us the correct traversal. Okay. One thing I'll go over that some of you I've shown this to, but if I would have had a segmentation fault in that program, okay, I would have needed to do the following. So I want to do the C19 P1.cpp. That's the basic idea, but I have some options here. I have to do a dash G. That's for the GDB debugger. And then I can do the dash O C19P1.exe, and then finally that name. Okay. It's the dash G that we're adding. That's the important part. Okay. Then I can run GDB on the dot slash C19P1.exe. Okay. When you get in here, you just type in run. It's going to run your program and it'll stop it when it has a problem. Answer yes, you want to do that. Okay. And in my case, it was fine. So it exited normally. Okay. If there would have been a segmentation fault or some kind of illegal instruction or whatever, it would have stopped and shown us where the problem was. Okay. Then a quit gets you out. So knowing how to use the debugger is a valuable tool as we move forward in this class. There are lots of chances to have segmentation faults. Okay. Okay, so that is the code. I just exited it out. So anyway, so that should be good. So yeah, if you, I'll go ahead and put a copy. I'll replace the copy that's in the /srv/csc2180 directory with this corrected version. The homework for this time is to expand that. I want to make sure you have this correct before you move on to the other stuff. Okay. So if you have any questions over the weekend, you can text me and I should be able to get back to you at some point. I won't have a computer, but I should have, I'll have my phone with me for sure. Okay. If not, see you guys on Monday.